So this turns out to be a pretty cool thing to do. We're going to complete the square on the generic equation ax squared plus bx plus c equals 0. It doesn't have any numbers in it, but let's keep on doing this anyway and we'll come up with a surprising result. Alright, so we'll use our normal completing the square procedure. So the first thing we'll do is move that c constant over to the right side. And then we're going to divide everything by a so that we make the coefficient of the x squared term 1. Alright, and then we want to add the square of 1/2 of the coefficient of x to both sides, and 1/2 the coefficient of x is b over 2a. So we square that, add it to both sides, and I'll just go ahead and square it on this side, so it's b squared over 4a squared. And now we just identify our nice perfect square here. That's x plus b over 2a and quantity squared. Remember, that's the whole idea behind completing this square, is we want to make this perfect square on the left side at the expense of accumulating some junk on the right side that we'll deal with later. And we can just get a nice common denominator for those two terms, so we make this b squared minus 4ac all over 4a squared. This should be looking a little bit familiar. Okay, we'll just finish off this equation. B squared minus 4ac all over 4a squared. And now we take the square root of both sides. Plus or minus, and we'll just we'll leave this upper part in the radical. It's not an easy square root to take, but the square root of the bottom we can do pretty easily. And then we can just go ahead and move that b over 2a on the left side over to the right side by subtraction. And we come up with a great result, which you know as the quadratic formula. So you can see that the quadratic formula and completing the square are exactly the same thing. So whether you complete the square or use the quadratic formula, you have to get the same result.